Problem 61, Quantum Mechanics. The question is, consider a system of two non-interacting identical fermions, each of mass m, in an infinite square well potential of width a. The composite wave function for the system with the total energy E is equal to 5 pi square h bar square by 2m a square is. In the question, it is given that two non-interacting fermions are placed in infinite square well potential. The total energy of the composite system is given. We have to find out the composite wave function. By looking at the total energy, we can say that the fermions can be filled in two ways. The first one, where the particle 1 having the energy, the particle 1 is at ground state and particle 2 is at first excited state, and in the second case we have the particle 2 which is at ground state and particle 1 which is at excited state. Here the value of nx1 square plus nx2 square is equal to 5. Therefore we can say that either nx1 equal to 1 or nx2 equal to 1 and vice versa. Since the fermions can be distributed in two different ways, we can have the composite wave function. Now in the case of fermions, they have the antisymmetric wave function. Therefore we can say psi space is equal to psi1 x1 psi2 x2 minus psi1 x2 psi2 x1. Here we have neglected the spin part because it is given in the question to ignore the spin, where psi1 x1 psi2 x2 corresponding to the first filling and psi1 x2 psi2 x1 corresponding to the second type of filling. Now what is psi1 x1? For a square well potential of width a, we can say that for a particle is at x1, psi1 x1 is root of 2 by a sin nx1 pi x1 by a. Now what is nx1 here? Here the particle 1 is at ground state, so nx1 is 1. Therefore we can say psi1 of x1 is equal to root of 2 by a sin pi x1 by a. What is psi2 of x2? It is a wave function of the particle which is at x2 or which is at the first excited state. The value is root of 2 by a sin nx2 pi x2 by a. We know that for the first excited state here, nx2 is equal to 2. Therefore the answer is root of 2 by a sin 2 pi x2 by a. Now let us consider the another kind of filling where the second particle is at the ground state. That is, here nx2 is equal to 1. Now what is psi1 of x2? That is the wave function of the particle when the particle 2 is at ground state. That is equal to root of 2 by a sin nx2 root of 2 by a sin nx2 pi x2 divided by nx2 pi x2 divided by a. Now here nx2 is again equal to 1 because the particle 2 is in ground state. Therefore the answer is root of 2 by a sin pi x2 divided by a. Similarly, we can find out what is the wave function of the particle 2 which is in the first excited state. This is also a possible combination. Therefore psi2 of x1, that is root of 2 by a sin nx1 pi x1 divided by a. Here nx1 represent the first excited state having nx1 that is equal to 2. Therefore psi2 of x1 is root of 2 by a sin 2 pi x1 by a. Now once we have psi1 of x1, psi2 of x2, psi1 of x2, psi2 of x1, we can calculate the composite wave function psi space of the fermionic system, that is 2 by a sin pi x1 by a sin 2 pi x2 by a minus 2 by a sin pi x2 by a sin 2 pi x1 divided by a. Therefore, we can say that option A is the correct option.